Hello. So we are going to start chapter 12, and chapter 12 is, I think, one of the most challenging things in math. At least it's challenging for me, and it was definitely challenging for little Karen in fourth grade, and that is measurement conversion. So, one of the things that I've learned about measurement conversion that I didn't know, that little Karen didn't know, is that you can set up an equation to convert measurement. And when you do that, it makes it a lot easier. So I'm going to show you every time we do measurement conversion, I'm going to show you how to set up an equation so that you can do the problem really easily without too much difficulty. So we're going to go ahead, I'm going to share my screen and we're going to look at, I already set up my paper. So we're doing lesson 12.0 and we're going to go from page 154 to 156. Now, they're going to ask us to practice some things. And the reason why they want us to practice is because these are all the skills that you use when you're converting measurement. So let's look at our page right here. We have, this looks like they're in the kitchen. We have a child saying the weight of the potatoes is 5 kilograms. Kids, can you help me weigh the vegetables? We have to use the food scale to weigh them. And she's asking, how much is that in grams? So in order for us to be able to do that, we have to know the conversion rate, how many grams are in 1 kilogram. And then we can write out a little equation to solve it pretty easily. So this recalling of prior knowledge that we usually do is going to ask you to do some interesting things. First, we're going to remember that we can add fractions and that when fractions have different denominators, we have to change and convert the fractions so that they have the same denominator. So I know that 1/2 plus 1/4 is equivalent to 3/4 because 1/2 is equivalent to 2/4. We also know that we can multiply a fraction by a whole number. So I can take 3/4 times 24, and that's the same thing as 3 times 24 over 4, because this 24 could have a 1 underneath it. And then I know that that gives me 72 fourths, which is a really improper fraction. So I can go ahead and divide it and I get 18. So this is a skill, multiplying a fraction by a whole number. It's a skill that you're going to have to know to do measurement conversion. Same thing with adding fractions. We're also going to have to remember how to divide whole numbers, right? So we remember that when we do long division, we remember that if we have a 3-digit number, this is the hundreds place, this is the tens place, this is the ones place. Okay? Now, we're going to do a few problems together, and these are they're just straight up equations, just so that we can practice measurement conversion skills before we move on and we actually start converting measurements. So we're just honing our skills because learning fractions was a long time ago. And also long division was a long time ago. So let's look at number 1. Number 1 has us adding 1/3 plus 5/12. And it says that they equal green box. So remember, you guys were still in workbook A, so you were still doing a little bit of fractions. Remember that we can't add these together because they have different numbers as denominators. So we're going to have to convert this number right here to a 12th. So we're going to multiply the top by 4 and the bottom by 4. And that's going to give us a 12th. And it's going to give us 4/12. This is an equivalent fraction. We just multiplied the top by 4 and the bottom by 4. And now we end up with 9/12. Now, 9/12 is not in simplest form. So I can divide the top and the bottom by a number. Let's see if we can think of what number we could use. 12 is an even number, but 9 isn't, so we can't divide by 2. I know a lot of you just instantly divide by 2, or you want to. I know my 3 times tables, and I know that 9 and 12 are both divisible by 3. So I'm going to divide the top and bottom by 3. And that's going to give me 3/4. And that is in simplest form. Okay, let's look at number 2. Number 2 is very similar. We're adding 5/6 plus 2/3 equals green box. So again, until the denominators are the same, we cannot add them. My lights will not go back on. There we go. I have to throw softballs with both hands to make the lights go on. So these numbers have to be the same. The denominators have to be the same. It is easier for me to take a lower number and make it into a higher number. So 3 times what is going to equal 6? I'm going to take 2 on the top and bottom, and that's going to give me 5/6 plus 4/6, and that's going to give me my green box number. And unfortunately, that has given me an improper fraction. 9 is too big to be on top of 6. So I'm going to go ahead and I'm going to divide it. Remember, this line in fractions is the same thing as this, right? It's a division sign. These numbers are the dots. So I'm going to go ahead and I'm going to say that 6 will go into 9 one time. And I get 1 3/6. Now 3/6 can be simplified. It's equivalent to half. If I divide the top by 3 and the bottom by 3, I get 1/2. All right, let's look at, I'm going to give myself a little room and I'm going to come down here for number 3. So number 3 is 5/8 plus 1/4. Again, these do not have like denominators, so I'm going to convert this one into eighths. In order to do that, I'm multiplying the top and the bottom by 2. And so that's going to give me 5/8, oops, plus there's a hole in my desk, and whenever I hit that, it gets sloppy. So this is actually going to be 2/8. When I add these together, it equals 7/8. And that fraction is just fine. It's in simplest form. I can't divide by any number to reduce it. So my answer is 7/8. I'm going to put a green box around it. Tricky. Okay, now let's look at number 4. So remembering back when we had fractions of a set, if we have this is going to get converted to this. I'm going to make this into a 1 because whole number 56 can become a fraction if you put a 1 underneath it. So this is the same as 3 times 56 over 8. Because 8 times 1 is 8. Now, I don't know what 56 times 3 is, so I'm going to come up here and I'm going to multiply it. I get 168 eighths. That is a terrible fraction. So again, remember, this is the same thing as a division sign. So I'm going to just divide. Remember, this is going to be my hundredths. My tenths. My tens. And this is going to be my ones. So I'm looking at the hundreds place and I'm saying, 8 will not go into 1. So it goes 0 times, and I end up with 0. I subtract and I get 168. Now I'm looking at the tens place because this is the tens area, tens place. So how many times will 8 go into 16? Twice. And 8 times 2 is 16. But because it's in the tens place, it's 160. Then I'm going to go ahead and bring down the 8. I'm subtracting the 8, and 8 will go into 8 one time. So I know that my answer is going to be 21 because I have no remainder. Okay. All right, let's look at number 5. Number 5 is 5/6 of 33. So remember that when we see the word of, that's the same thing as times, right? So this is really going to be 5 times 33 over 6. 6 times 1 is 6, 5 times 33. And if I multiply 5 times 33, that's 15 and 165 over 6. And this is the same thing. Remember, this is a division problem. So I'm going to go like this and I'm going to divide it. This is going to be my hundreds. This is going to be my tens. This is going to be my ones. And we're going to subtract as we go. So I'm looking at the hundreds place, right? And I have a 1 there. 6 will not go into 1. So it goes 0, 0, 0. Now I'm looking at my tens place. 6 will go into 16. It goes 2 times, right? And that's 12 with a 0 on the end. And when I subtract, 6 will go into 45. Let's see, 6 times 6, 6 times 7 is 42. So I get 27 and 3/6. Now, 3/6 is not in simplest form. I could divide the top and bottom by 2, and I would get 27 and a half. Okay. All right. Let's attack number 6. And then we have 2 really hairy long division problems that we're going to have to deal with. So we have 4/5 times 90 equals green box. So remember, we put this over 1 because we want to make it into a fraction. And the way to make a whole number into a fraction is to have a 1 as the denominator. Now that's the same thing as 4 times 90 over 5. And this is going to be 360 over 5. And that's going to equal 360 divided by 5. This is going to be our hundreds, our tens, and our ones. So I look at the number that's in the hundreds place. It's a 3. 3 is too small. I can't take 3 and divide it into 5 groups. So I'm going to put a 0 up here. And when I multiply 0 times 5, I get 0, 0, 0, 0. Now I'm going to look at the number that's in the tens place. That's 36. So that I can do. So I'm going to multiply by 7 to get 35. But because it's in the tens territory, it's not 35, it's 350. Because we're multiplying it by a number that's in the tens place. And then when, oh, whoops, I'm sorry, 360 and then 350. So we get 10 when we subtract. And 5 will go into 10 2 times. All right, so we end up with 72 as our answer. So if I have 90 objects, let's say I had 90 little cubes, and I divided all 90 into 5 groups, 4 out of the 5 would be 72 cubes. All right, let's do some hairy long division. Ooh, these look difficult. So we're going to do number 7. I'm going to do it over here, and then we'll do number 8 over here, okay? Here we go. This is 12. I don't think we've done double digit before. I think they're being extra harsh with you. I think they're being extra harsh. So they're telling us already that we're going to have a remainder. All right, so if I have a number that has 2 digits over here, this is my hundreds place, remember? This is my tens place. This is my ones. So I cannot do this because there's no way that I can take 7 and break it into 12 different groups. So I'm going to put zeros here. And now I'm going to look at the number that's in the tens place, which is 78. And if I know my 12s times tables, this isn't that bad. So if I know that I have, let's see, 12 times, let's see, 72, right? Sounds like it's going to be about the right number. I'm peeking and looking over at my 12s because my brain is, so it's 12 times 6, right? So I'm going to put a 6 there. And it's, because it's in the tens place, it's not 72, it's 720. Then I'm going to subtract. And now I'm going to ask myself how many times 12 will go into 69, right? And I'm cheating and I'm looking at my 12s. And I know that they will go 5 times 60. And so I get 65, remainder 9 as my answer. Okay, you ready to do 8? 8, we can't cheat. So I'm going to show you when we do 8, I'll show you a little trick that I came up with when I taught 6th grade. It was a pretty good trick, and I'll show you how to do it because number 8, we don't know our 15 times tables. And we also know there's going to be a remainder because they're telling us. They're saying remainder green square, right? So that's kind of helpful to know. Now, here's what I do. I make a little times table chart off to the side. as I'm working. If this gets kind of difficult and hairy and I can't figure it out, I might do, what's 15 times 4, 15 times 5, 15 times 6, and I just write them next door. Let's see if it's going to get difficult like that, or if they're going to keep it easy on you. Oh, this is thousands, huh? This is hundreds. This is a big number, I forgot. This is tens, and then this is ones down here. Sorry, this is super sloppy. Thousands, hundreds, tens, ones. So I'm going to start out by saying, how many times will 15 go into 1? It won't. So then I subtract and I get the exact same number. Now I'm going to look at the number that's in the hundreds place. My number in the hundreds place is 14. So 15 will not go into 14. This is a tricky one. So now I'm in the tens place. 15 will go into 144. I don't know how many times. I know that 15 times 10 is going to be 150. So I'm going to try 15 times 9. So right over here, I'm just making a little chart. And it goes 135, and it's 9 times. Now, because we're in the tens place, it's not 135, it's 1,350, right? Now I'm going to subtract. I got to do some regrouping over here. And I get 95. Now I'm going to ask myself, this isn't really very helpful. I know it's going to be less than 9. So I know that 15 times 15, or 15 plus 15 is 30. So if I know that 15 times 2 is 30, then I'm going to say that needs to be 15 times 6. Let's see if 15 times 6 gets us close. Ooh, 90, nice. So I think that's going to be our ticket. It's going to go 6 times, and we're going to go like this, and we're going to have a remainder 5. So our answer is 96, remainder 5. Now, I did not do the check step for either of these problems. Shame on me. So I'm going to do that right now. I'm going to go back here to this problem, and I'm going to multiply. Remember that you can take this number, right? This is the divisor. You can multiply it by the quotient, and it should give you the dividend. So I'm going to do that, and I'm going to add my remainder in. Plus remainder 9 equals 789, and that's this. So I know that my answer is correct. This is double digit division is tricky. So I always, even when I'm doing it on my own, I check it. Let's check this guy because this was a bear. So we're going to check, we're going to take 96. We're going to take the quotient times the divisor, and it's going to give us the dividend once we add the remainder in. And why did I write remainder is R? This poor problem. Okay, so I'm going to take 96 times 15. Now, if you don't want to do double digit, you can think back to the days of lattice where we did this. And remember, you're not adding these in, but you're going to do 0, 5 plus 6 is 11, plus 3 is 14, 0 plus 9 plus 1 is 10, plus 4 is 14. So we got 1440, plus we have to add the remainder, which first I wrote was R, remainder R. It's actually 5. So our answer is 1,445. And so we know we did it correctly. So just doing an extra little check step doesn't take that long. It's a chance for you to practice some skills too. And then you know that you did the problem correctly. All right. So thank you for joining me. We will start measurement conversion the week after this, now that we know these skills. All right, so thank you for joining me. I will talk to you later.